All right, let's do some. So last time we did some algebra. Let's do some geometry here. It's gonna be pretty simple. It's basically just a review, nothing really new. So the first question is asking us to find the equation of a line that passes through 2, -5. So we're given a point. So let's say that's 2, -5. We're given this point, and we're asked to find the equation of a line under different circumstances. The first one is when the slope is 3. So we're provided the slope. We know a point as well. We know the slope, we know the points. How do we come up with the equation? It's going to be in this form. Keep this in mind. Or you can, if you want, you can also have it in this form. So how would we do A? It's pretty simple. It's just a plug and chug. So if you do it using the top formula, okay, look at this. It's very simple. If you use it using the top one, you're given the m value, you're given a point. The only thing you don't have in this equation, you only need two parameters. You need the m and you need the b, right?
Mm-hmm.
So the only thing we don't have is the b, and the only way to find it is if we plug in the given x and y value and the m value. So we're going to plug x, y, m into this equation and then solve for b. That's very simple. So it'll be -5 is equals to -3 times 2 plus b. Therefore, b is 1. So the equation is y equals -3x, slope is -3, plus 1. Cool?
Mm-hmm.
Very simple. Part B says parallel to the x-axis. So now we don't have the slope, but the condition is that we have to be parallel to the x-axis. So in other words, see, this is the x-axis. Our line has to go through this point and be parallel to the x-axis at the same time. And the question is, what is the equation of this line? Any ideas what it is? What's the slope? Let's first talk about the slope.
It's the same.
So what is it? What's the slope of a horizontal line?
0.
0. So it has no slope, right?
Mm-hmm.
So y equals mx plus b. If this goes through the point 2, -5, it must go through 0, -5. So you have your y-intercept.
Mm-hmm.
Slope is 0, so this entire expression will be 0. So y will simply be your y-intercept. So y equals -5. And you're done. Cool?
Mm-hmm.
Part C, parallel to the y-axis. Now, instead of being parallel to the x-axis, we're now parallel to the y-axis. So your point is down there still. So now we're looking for the equation of this line that's parallel to the y-axis and goes through 2, -5. How do we go about doing this one? Is it going to be in terms of y equals to, or is it going to be x equals to for a vertical line? It's going to be x equals to. Why?
Mm-hmm.
Because the slope of a vertical line, if you plug in numbers here, you'll see that the slope is going to be rise over run. So the rise here is 2 units, but the run here is 0 units. If you just take any 2 points. So a vertical line has a slope of infinity or an undefined slope. So we can't write the line in terms of y because this form requires a slope y equals mx plus b. So what we do with vertical lines is that we write it in terms of x. It's just going to be x equals to whatever the x value at that point is.
Mm-hmm.
And that's it. That's the answer for C. Did that make sense?
Yeah.
So vertical, it's going to be in terms of x equals something. Horizontal, it's going to be in terms of y equals something. There's a part D. Parallel to the line 2x minus 4y equals 3. So if something is parallel to this line, what do they share?
The slope.
Slope. What's the slope of this line?
It's 2.
Is it? So be
Mm.
careful. It's not in the right form. It's not 2. Is it? It might be 2, but it's not in the right form right now. So let me just put it in the right form. So it'll be negative 2x plus 3, right?
Mm-hmm.
So y will be negative 2 over negative 4, so that's 1 over 2x minus 3 over 4. 3 over negative 4 is 3 over 4. So there we go. So the slope is actually not 2, it's 1 over 2, okay?
Mm-hmm.
So for this point, we know it's going to be y equals 1 over 2x plus b. They're going to have the same slope because they're parallel lines. How do we find the b value? There's only one way to find the b. Just plug in the point as x and y. So negative 5 equals 1 over 2 times 2 plus 4. So b is negative 5 minus 1. So b is negative 6. And that's the answer. Okay?
Mm-hmm.
So again, linear equations, kind of simple. You just have to plug in the point sometimes to find the slope or to find the y-intercept. Okay, what about something like this? Well, what's the equation of a circle? What's the general form of the equation of a circle? Do you remember? Well, linear lines is y equals mx plus b. What about a circle? It's a degree 2 function. So it's this. Equation of a circle is y squared plus x squared plus y squared equals r squared. This is if the circle has a center at the origin. At origin, that's one form of the equation of a circle. Another form is this. And then for this one, the center is at h comma k. So there's two equations. In the question, have they given us the center?
Yes.
Yes. So we know h and we know k, so we're going to plug it into this equation. So x plus 1 squared plus y minus 4 squared, okay, equals. Now the only thing we're missing is the radius of the circle. Now think about it. You have a point at negative 1 and 4. Negative 1, 1, 2, 3, 4, right there. This is the center of your circle. Your circle has to pass through the point 3 comma negative 2. So 1, 2, 3, 1, 2, negative 2. So your center is here, but your circle has to pass through this point. So it'll look something like this. How do we find the radius of the circle? You're given 2 points, right? How do you find this distance? Would that be the radius?
No.
It would be the radius, right? Because your circle again looks something like this. Not a perfect drawing, but the center is here and it's gonna pass through this point, right? So if we drew a straight line from the center to that point, what does this line represent? It's the
The
radius,
radius.
right? It's the radius. So again, we're given 2 points. We need to find the distance between them. It's easier than you think. How do you find the distance between 2 points? I'll give you a big hint, okay? What you can do is you can turn this into a triangle. You can turn it into a right angle triangle. The distance between the 2 points is simply the hypotenuse of this triangle. Do you agree?
Mm-hmm.
Okay, so let's find the side length. So what's the length from here to here? On the y, we go from -1 to, sorry, on the y, we go from 4 to -2. So how many units long is this side?
6.
6. What about the other side?
4.
4. So the hypotenuse would be 36 plus 16. It'll be the square root of 52. Okay?
Mm-hmm.
So the only thing we were missing was the radius. If the radius is square root of 52, what's r squared?
It's 52.
It's 52. So there you go. This is the final answer for this question. Again, it's not that difficult. You just need to know the general form of the equation of a circle. Now let's look at another question, which also involves circles. It's the same general equation. So we're given an equation, but it's not in the right form. A circle, if it's in the origin, has to look like this. If it's not in the origin, it has to be in this form. This equation that they've given us, it's not in the right form. So we have to somehow take this and turn it into this. Okay?
Mm-hmm.
Notice we have to turn it into a whole square. There needs to be a bracket and there needs to be a squared on the outside of the bracket. Now this is something that we did last week. What is this process called? We have x squared, right? But we want to turn this into x minus something whole squared. This process is called completing the square, okay?
Mm-hmm.
So you have to complete the square. But you have to do it twice here because you have two different brackets, one for x, one for y. So let's attack it one bracket at a time. So you're going to pair the like terms together. Move the x with the x, the y with the y. And these are the steps for completing a square. Step number 1, you're going to take the a value out of the first two terms, which means you can ignore the constant term. So here the a value is 1 for both x squared and y squared. How do you find the a value? Well, you see what's attached in front, okay, here. Because the general form of a quadratic is this. A is whatever you're multiplying with your x squared term. So in this question, our a is 1. So if you don't want to, you don't have to even pull it out, but I'm just going to do it like this. And that's your first step. Your
Mm-hmm.
second step is to not take, but to add and subtract. Notice you have a b value inside the bracket. So what you do is inside the bracket, okay, inside the bracket, you're gonna add and subtract half of b squared. So let's look at the first bracket, this one. What's our b value here? B is the thing that's multiplied with x, just with the
Negative.
x. It's 6, right?
Mm-hmm.
So what you do is you add and subtract. So b value is 2. That means, sorry, b value is 6. So 6 over 2 squared will be 3 squared. That'll be 9, okay? B
Mm-hmm.
over 2 squared is a 9. So we're going to add a 9 and we're going to subtract a 9. We're going to do the same thing in the other bracket. What's b value in the other bracket?
10.
10. So half of b squared will be 5 squared, right? 25.
Mm-hmm.
Now this is probably the most important step. What's going to happen is that the first three terms inside the bracket, the first three terms only, they always make up the whole squared. So look at this. 1 on the outside is on the outside. Squared, sorry, bracket, bracket. And now what I'm going to do is I'm going to pull the square out. So what I need to do is I'm pulling the square out. So x on the inside is just going to have a power of 1 because I've kind of pulled the square outside. I need to
Mm-hmm.
do the same thing with the constant that I found here. So half of b squared was 3, okay? This part is a little bit confusing. The sign drops in as it is. And then what we do is we take the square root of this number because we're pulling the square out. So you have to square root the number that's on the inside.
Mm-hmm.
So minus 3. So that's the first three terms make up that whole squared. What doesn't make up that whole squared is this minus term at the end. So what we do with the minus term is that we pull it outside of the bracket. To pull it outside of this bracket, you have to multiply it with the a value in the front. So it's going to become minus 9 times the a value in the front. It's going to be the exact same thing in the other bracket. Can you tell me what goes in this bracket?
Y plus 5.
Yeah, y plus 5 squared. And then this negative 25, we have to pull it out. And to pull it out, you have to multiply it with the a value in the front. So it'll be minus 25 times 1, and then the only thing that's left at the end is this plus 9 equals 0. Minus 9 plus 9 cancels out. I'm going to move this minus 25 onto the other side. Therefore, look at this. You have 1x minus 3 squared plus 1 y plus 5 squared is equal, so there's a 25 on the other side, so that becomes a 5 squared. Now that is finally in the right form.
Mm-hmm.
So the center of the circle is at 3 and negative 5, and the radius of the circle is 5 units. So 3, so it's a 5, you can just like kind of measure it and draw it if you want to. Cool?
Mm-hmm.
Here's the thing about circles. If you look at the general form of a circle, what's the a value always going to be? Look at this. What's the a value? It's always going to
1.
be the same thing. It's always going to be 1. So if your a value, if you're talking about a circle and your a value is something else, then something went wrong. With that being said, though, you could get something like this. Is the a value here 1?
No.
No. So this is not a circle. Although it has x squared and r squared, the a value is not 1. So this is not a circle. This is an eclipse. Know the difference between them? Circle is like this, right? Well, it's not a perfect circle, but eclipse is a little bit, it's not symmetrical in all directions. It's like that. You can also have like a
Mhm.
long eclipse. You can also have like a mirror eclipse. So that's an eclipse. It's only symmetrical in one direction. You can cut it one way, and now you'll have symmetry. But it's not like a circle. Circle, you can cut it in any direction. You'll have symmetry.
Mhm.
So that's the difference between an eclipse and a circle. One of them will have an A value of 1 always. Let's look at this question. So we're given 2 points. Let's draw them out. 5 and -12. So -7, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. -7, 4. 1, 2, 3, 4. And then 5, 12, which is just going to be 1 unit up. So we're given these 2 points and we want to connect them. It's asking us for the equation of the line. All right, so we're trying to find the equation of that straight line. How do you find the slope between 2 points? So for part A, it says find the slope. How do you find the slope between 2 points?
Y2 minus Y1 over X2 minus X1.
Exactly, it's just the rise over run. So it'll be -12 minus 4 over 5 plus 7. Do you agree?
Mhm.
So that's -16 over 12. Does 12 go into 16? I don't think so. -8 over 4. So -8 over 6. -4 over 3. So we have the slope. That's the answer to part A. Part B, find an equation of the line that passes through A and B. So we have the slope of the line. How do we find the equation of the line? So y equals mx plus b, right? We just found m.
You can plug in a point.
Yeah, you can just plug in either of the 2 points. So I'm going to plug the first point. So y, so -4, 7 is equals to m, which is -4 over 3 times x. And I'm doing mx plus b. So that means b will be -7 plus 16 over 3. So that's -21 plus 16 over 3, right?
Mhm.
That is -5 over 3. 2 minus x1. So I got a negative y-intercept. But on my diagram there, I have a positive y-intercept. Which one is wrong? 7 plus 4 divided by 3. Let me just plug this in. -7 plus 16 divided by 3. So this math is right. 7. This is right. What about the slope? -12 minus 4 divided by 5 plus 7. That is also right. So the diagram is somehow wrong. Cool. So the sketch is somehow wrong. We're going to ignore the sketch for a second. So we have the equation of the line. Y equals mx plus b. M was -4 over 3x. And b was -5 over 3. Cool?
Mhm.
Part C says find the midpoint of the segment AB. How do you find the midpoint between 2 points?
You add them and divide by 2.
Exactly, very simple. To find the midpoint, you simply add them and divide by 2. So it'll be for the x midpoint, it'll be this. For the y midpoint, it'll be this. So that's -1. That's -8 over 2, -4. Easy peasy. Part D, find the length of the segment AB. How do you find the length between 2 points? It's asking you for the distance between 2 points. Any ideas? Distance between 2 points.
Do we turn into a triangle?
Yeah, we turn it into a triangle. So you have this point, 5, -12. Okay, I see why the sketch was wrong because I messed up the axes. So you have 1 point, 5, -12, and then you have another point, -7, comma 4. So -7, comma 4, +4. So now let's turn this into a triangle. From 4 to -12, +4 to -12. What's the distance on the y?
It's 16.
16. From -7 to +5, what's the distance in the x?
12.
12. So we have 16 squared plus 12 squared, the square root of 16 squared plus 12 squared, it's going to be 20 exactly. So that's the length of the segment AB. Cool?
Mm-hmm.
Pretty simple. You can also use the distance equation if you wanted to, which looks like this. You just take the difference of the x squares and the y squares, you add them up and you take the square root. That's just the Pythagoras theorem with the triangle we just did. Part
Mm-hmm.
E, find an equation of the perpendicular bisector of AB. Okay, what is a perpendicular bisector? Any ideas on what a perpendicular bisector could possibly be? It's in the name.
Is it like a perpendicular line going through the middle of
Exactly.
AB?
So it'll be this line right here. So it goes through the point -1, -4. So that's the midpoint. We found it before, okay?
Mm-hmm.
So we're looking for this line that passes through that point, and the angle between these two lines is 90 degrees. In other words, this line is perpendicular to the other line. So how do we go about solving this? So for the perpendicular bisector, again, it's a straight line. It's easier than you think. It's going to be in this form, y equals mx plus b. We know that this line is perpendicular to this line. This line has a slope of -4/3. What's going to be our new slope?
-3/4.
So it's the negative reciprocal, right? So it'll become positive, okay?
Mm-hmm.
It'll become positive. So it's 3/4, okay, like this. So y equals 3/4x plus b. Now we don't know the y-intercept for this line. We need to find the y-intercept. To find the y-intercept, every single time, you're just going to plug in a point. What point do we plug in here to find the y-intercept? We know that this perpendicular line goes through the midpoint of the other line, right? So we only have one point that we know. So that's the only point we could possibly plug in. So to
Mm-hmm.
find the b value here in part E, we're going to plug in the midpoint from part C. because that's the
Okay.
only point these two lines share. So we're going to plug that as y and x, and that should give you the answer. So y is -4 equals 3 over 4 times -1 plus b. So b is going to be -4 plus 3 over 4, right? That's
Mhm.
-16 plus 3 over 4, and -13 over 4. There we go. So the perpendicular bisector has this equation. Part F, find the equation of the circle for which AB is a diameter. Again, it's easier than you think, okay? So you have these 2 points. You don't really need anything else. So what we want to do is, remember, you also have the midpoint. You also have this midpoint. We want to turn this into a circle. We know the diameter is 20 units. What's going to be the radius? The
It's
diameter is 20. It's 10, right? So we already know the R value. For part F, the R is going to be 10 units. Do we know the center of the circle? It's going to be the midpoint between those 2 points. We already have it. H comma K is this right here. If we're turning it
Mhm.
into a circle, the center of the circle must be at the midpoint. So H comma K is -1, -4, and then you're going to plug these into the circle equation. X plus 1 squared plus y plus 4 squared equals 10 squared. And that's the answer to part F. Again, not super difficult, right?
Mhm.
Just circles, you just have to know the general form of a circle. And the other things, such as finding the distance between 2 points, is prerequisite stuff. So now we're going to graph inequalities, which is going to be a little bit tricky here. Let's just graph something simple here. Y equals x plus 2. So this is just a review of inequalities. That's just a straight line, goes through 2, has a slope of 1, right?
Mhm.
So it looks like this. Now, what if the question had asked us to graph this? Y is greater than x plus 2, okay?
Mhm.
Y is greater than. You only have two options when you're graphing inequalities. Either you're graphing on top of it, so you're going this way, or you're going this way. Can't be both at the same time. So now the question you want to ask yourself is, which direction am I going? And again, it's easier than you think. What you want to think about is, let's say for this x value, my equation requires my y value to be bigger than this straight line, right? It requires my y value to be higher than the straight line, not lower. Right now, my y value at this point is 3. I need my y value of the inequality to be bigger than 3. So that means for this x value, my y value for the inequality must be higher, right? And this applies to any x value. So for every x value, you want a y value to be higher than the line. And you'll see that that'll give you this direction. So this is the graph for y is bigger than x plus 2. Cool?
Mhm.
If it said less than x plus 2, then what would you do? You'll go in the opposite direction, right?
Mhm.
So I just want to make something clear here. There's a dashed line here. That dashed line is the equation of the original y equals x plus 2. And it's dashed here because it's not inclusive. You see the inequality is an open circle, just strictly
Mhm.
greater than. That's why it's a dashed line. However, if you make it greater than equals to, then the dashed line now becomes a solid line, okay? So when
Okay.
you're graphing inequalities, It's either going to be a dashed line or it's going to be a solid line, depending on whether it's inclusive or it's exclusive. So using this logic, let's try doing part A. So the region is that y is trapped between -1 and +3. So -1 is down here, +3 is up here. How do you graph y equals -1? What does a sketch of this look like?
It's a horizontal line.
Yeah, it's a horizontal line that goes through 1. Now notice that it's a closed circle thing because it's greater than equals to, right?
Mm-hmm.
So it's not going to be a dash line. It's going to be a solid line. So we're going to go through here at 1. We're going to go through here at 3. And this goes to infinity in both left and right directions. And now our y is the area in the middle, right? So the answer to this question is going to be this shaded area between y equals -1 and y equals 3. Cool?
Mm-hmm.
Very simple. B is tricky. I don't know what's going on with B. So let's see B. Because now we have multiple conditions. So we need the absolute value of x to be less than 4. Let's focus one thing at a time. Absolute value of x less than 4. So what are the values of x that it can take? Can x be 5?
No,
What about -3?
it can't.
X can't be -3? Let's check. Is this true or false? That's true, okay? So let's come up with a bound for x. X can be -3.99, right?
Mm-hmm.
Can it be exactly 4 or exactly -4? No, it cannot. Because -4 is not strictly less than 4. It's equal to 4. So this statement becomes this statement, which is incorrect. So x cannot be strictly positive or -4, but it can be anything. Okay, x can be anything. See if this makes sense to you. From -4 to 4 with an open circle. 4 itself is not included. Any value in that range would make that equation true. The absolute value of x is less than 4, right?
Mm-hmm.
What about the other equation? Can you tell me what values would make that true? Can y be 2?
Between -2 and 2.
Yeah, it's between -2 and 2. And I'm just going to draw it this way. So 2 and -2. Open circle or closed circle?
Open.
Open circle, exactly. So this is the range for your x. This is the range for your y, right? And it's asking you, it says and. If it said or, this would be the answer. It says and, so now you have to combine it. And look at it, it just turns into a rectangle, basically. So imagine a number line, or a grid, 0, -4 to 4 on the x, 2 to -2 on the y. So the answer to this question, again, it's inclusive, so it's going to be dashed lines. So it is this rectangular area. Okay?
Mm-hmm.
So it's a little bit complicated. You have to kind of combine two different inequalities. Okay, this one's very simple. So you have a straight line. You know the y-intercept is 1. What's the slope?
It's 1/2.
-1/2. So for every 1 unit for every 1 unit you go across, you go -1/2 or 1/2 unit down. So your sketch looks something like this. We don't have to be super precise here. Now look at the inequality. Your y, okay, you require your y to be less than 1 minus 1/2x. So now think about it. Your y value needs to be less than what it is currently. So right now your x, at the x value of 0, your y value is 1. Your y value, your new y values need to be less. So are we going down or are we going up the inequality? What do you think?
Down.
Down. Right now it's 1, you need it to be less than 1, so you need it to be somewhere here. As you can see, it's lower on the graph. So the inequality for this needs to be with a dash line, looks something like this. And with a dash line because it's not inclusive. Cool?
Mm-hmm.
Pretty simple. Okay, what about this one? Y is greater than. Now, what kind of a function do you have? Is it still linear?
No.
It's a quadratic, right? So always start off with a sketch. How do you graph this? What does x squared minus 1 look like? Where's the y-intercept? Or the vertex? They're one and the same in this case. It's at -1, okay?
Mm-hmm.
So a sketch of this curve looks like this. Okay, that's a straight line. That's not going to help us. Looks like this. And that point is -1. Now look at it, okay? It's again, it's easier than you think. We require our new y values, our inequality, to be bigger. The y values at that x value needs to be bigger than what it is. So if you look at our y-intercept, the x value there is 0, the y value is -1. We require our new values to be greater than -1, right? So are we going to be above this curve or lower than this curve?
Above.
Above this curve, right? So at every x value, we need it to be above. So this y value here, maybe I'll use a different color. This y value here becomes this. This becomes here. You'll see that every y value will shift slightly up. So therefore, your inequality is this area right here. And this, the boundary, is going to have a solid line because it's inclusive. So it's strictly between the curve, okay? It'll never go outside of the curve. So it'll be like this. And the area that you're interested will always be strictly inside of the curve. Because if you go outside of the curve, that means for some x value, your y value is lower. So that's why you're always going to be strictly inside of the curve and you're going to shade that area. Cool?
Mm-hmm.
Okay, what about this one? What is this an equation of? Ignore the less than sign. Treat it as an equals to sign. What is this? What are we dealing with here? We did a couple of these type of questions earlier today. Is it a quadratic? I'll give you a hint.
No.
What is it? Look at the a value of x and y.
It's a circle.
It's a circle. What is the radius of the circle? 2. X squared plus r squared equals x squared plus y squared equals r squared. So r squared is 4. That means r is 2. Okay.
Mm-hmm.
So we're dealing with a circle. Because there's no HK, we know it's through the center. So this is the center of the circle through the origin. And then our radius is 2. So we go 2 units in all 4 directions. So this is our circle right now. What does the new function need to have? The y values need to be less than 4. Okay?
Mm-hmm.
So is it inside the circle we shade or outside the circle?
Inside.
Inside the circle is right. And that's the answer. Cool?
Mm-hmm.
Very, very simple. There's one last question here. This is not a circle. This is what did I say this was earlier? It's an eclipse, okay?
Mm-hmm.
It's an eclipse. So this one is not an inequality. It's a little bit difficult to graph. There's a lot of steps. You'll do this in grade 12, I think. So to graph this, it's not the easiest. What I will tell you is that they kind of flip-flop. The a values are no longer 1. The a value for y applies to x. The a value for x applies to y. So what I mean by this, okay, a very, very rough sketch. You need to square root it, just like we do with the r value. So if you square root this, you get 4. If you square root this, you get a 3. And it's flip-flopped. Whatever happens to x applies to y, what happens to y applies to x. That means this 3 unit for x would apply to y. Your y would go 3 units in both directions. Your 4 units for y would apply to your x. So your x will go 4 units in both directions, okay? Like this.
Mm-hmm.
And then you kind of connect the points. It's not a circle, it's an eclipse, so it's gonna be fatter on one side than another one. So it looks kind of like that. We'll do more of this later. It's pretty long to graph this precisely, but that's the general idea. And it's not an inequality, so we can kind of move away from this here. Let's move on to some functions for the last 5 minutes. Um, cool. Let's work with this figure that they've given us. Again, I don't think this is very hard. I think all of them are gonna be 5 to 10-second answers each. Part A says state the value of f of -1. What's f of -1 from the graph?
It's 0.
It is, so f of -1 is not 0. So what does it mean? So what's the y value when the x value is -1? It's simple, right? So let's look at this. -1 is here. What's the y value there? -1, -2, right?
Mm-hmm.
Was that difficult? No.
No.
Okay, what about the next one? What's f of 2? Very simple again. You just look at what the y value is when the x value is 2. What is it?
It's almost 3.
I think we're gonna actually you're right. Estimate the value of f of 2. We're gonna say it's almost 3. So that this symbol here means approximate, okay? This one.
Mm-hmm.
So you can kind of say it's almost 3. Part C. Estimate the values for when f of x equals 2. What about now? What is it asking us?
What x is when y is 2?
Right, so when is the y value 2? Y value is 2 right here, right?
When x is 1?
When x is 1. Any other point? -3, okay? So you need to give both of them.
Mm-hmm.
1 and -3. 1 and -3. D, estimate the values such as when f of x equals 0. Again, it's going to be right here, maybe 0.5. And maybe right here, maybe -2.5. Cool?
Mm-hmm.
E, estimate the domain and range of f. So domain is the possible x values it can take. Looks like it's going from -3 to +3. Inclusive. What about the range? What are the possible y values this can take? So again, we just look at the chart. -2 is the lowest y value.
To 3.
2. Yeah, so it'll be -2 to 3. Easy peasy, right? Super simple
Mm-hmm.
question. But this is the kind of stuff you'll do in the beginning of grade 12 math, right? Let's do a difficult problem. Find the domain of this function. Why don't you man the denominator? If you man the denominator, what do you get? It'll multiply to -2, it'll add to 1. So the numbers are +2 and -1. Can you tell me what the domain of this function is by looking at this equation? So what are the x values that it cannot take? Okay, think about it that way. Can
One
x
and
be,
negative two.
say that again?
1 and -2.
1 and -2. Perfect. That's it. That's the domain of this function. Cool.
Mm-hmm.
Easy as that. You just simplify it. You see what gives you a 0 in the denominator. Okay. What about this one? Last one for the day. What value of x would make that denominator 0? If any. Is there any value of x that would make that denominator 0? The answer is no. Okay.
Mm-hmm.
There's no value of x that you can plug in there that would make that denominator 0. X squared plus 1, we were trying to see what values would make x 0 here. You get x is equal to the square root of -1, which cannot happen on a real number system. So that means for this question, the domain is at xer, can take any values. All right, let's call it
Mm-hmm.
there for today.
Okay, thank you.
See ya.